Hello, good morning students. Today we are going to discuss triangular law of addition of two vectors. So today we are going to discuss triangular law of addition of two vectors. Triangular law of addition of two vectors. Let us see. Here I am going to consider two vectors. One is A bar, another vector B bar. One vector is A bar, another vector is B bar. So these two are two sides of a triangle I am going to consider. I am going to consider a triangle in this pattern. These two vectors seems to be two sides of a triangle. This is one side, this is another side. So this seems to be what? Two sides of a triangle. This is one side and this is another side. So the two vectors are represented. So two sides of a triangle. That means here I am going to consider the two sides of a triangle. The two sides of a triangle are represented by two sides of a triangle are represented by two vectors. Two vectors, that means these two vectors. So the two sides of a triangle are represented by two vectors taken in same order. Taken in the same order. Two sides of a triangle are represented by two vectors are taken in the same order. What is the meaning of same order? So first vector head, second vector tail, both are meet at one point. First vector head, second vector tail, both are meet at one point. At the time these two vectors are we consider as taken in the same order. Same order. That means here the vector starts with the tail, end with its head. This vector also starts with the tail, end with its head. At the time, generally we call it as both vectors are taken in the same order. So the two sides of a triangle are represented by two vectors taken in the same order. Then the resultant of these two vectors, that is the resultant vector. The resultant vector means the resultant of these two vectors is represented by the third side of a triangle. The third side of a triangle, and it is also known as closing side. Third side of a triangle is nothing but closing side. So the resultant vector is represented by the third side of a triangle. Taken in opposite order. Taken in opposite order. Observe here. Here the both tails are meet, the both heads are meet. That's why we are going to take in opposite order. These two are taken in the same order. Observe here. Head of the first vector meets the tail of the second vector. So taken in the same order. But here what happened? Head of the second vector meets the closing side of the, that means closing side means here third vector. So resultant vector head and B vector head both are meets. That's why this is not same order. This is the reverse order. Both tails meets, both heads meets. It is taken in reverse order. That means the two sides of a triangle are represented by two vectors taken in the same order. Then the resultant vector is represented by the third side of a triangle, that is closing side, taken in opposite order. That means this is the third vector taken in opposite order. So this vector represents the resultant of these two vectors. That means resultant of these two vectors means addition of these two vectors, A bar plus B bar. Here this A bar plus B bar is not ordinary addition in algebra. It is not add like a scalars. We need to add in vector form. So A bar vector, B bar vector, we need to add these two vectors not like a ordinary algebra. How to add and how to calculate the magnitude of this resultant vector and how to know the direction of this resultant vector, we will see now. Note down. Right. Calculation of A bar plus B bar. So here A bar plus B bar is not a scalar, is a vector. A bar plus B bar is a vector. That means it has two things. One is magnitude. Second one is direction. Direction. Why? Because A bar plus B bar is a vector. One is magnitude. Second one is direction. We know that already. A bar is a vector. Its magnitude is nothing but modulus of A bar. That is the magnitude. Similarly, A bar plus B bar. How to calculate its magnitude? Modulus of A bar plus B bar. So that is we need to calculate. That is we need to calculate. And next one, direction also we need to calculate. How to calculate mod A bar plus B bar? How to calculate direction? We will see. That is only calculation of A bar plus B bar. First, we are going to calculate magnitude of A bar plus B bar. We will see now. Suppose I am going to consider again the same vectors. This is the A bar vector and this is the B bar vector. A bar vector and B bar vector. Here I am going to consider the two vectors. These are the two sides of a triangle. The two sides of a triangle we are going to represent it by two vectors taken in the same order. Now the resultant of A bar and B bar is nothing but the resultant vector we call, and it is represented by closing side of a triangle. And this is the A bar plus B bar. And now I am going to consider what is the magnitude of A bar. Magnitude of A bar, that is modulus of A bar. It is also known as A. Magnitude of B bar or modulus of B bar, it is also represented as B. Modulus of A bar plus B bar. Modulus of A bar plus B bar. That is I am going to consider one resultant vector. That is I am going to consider one resultant vector. A bar plus B bar. This is nothing but resultant of those two vectors. That is I am going to consider R bar. So R bar. Then mod A bar plus B bar I consider as a resultant vector R bar. Why? Because A bar plus B bar will give vector only. R bar is the resultant vector. Then modulus of A bar plus B bar is nothing but modulus of R bar. That is nothing but R. That is nothing but R. That means here I am going to consider a triangle. This is the magnitude of A bar vector. This is the magnitude of B bar vector. To calculate the magnitude of mod A bar plus B bar, that is magnitude of A bar plus B bar or modulus of A bar plus B bar, I am going to calculating magnitude. That means I required side length of the triangles. To calculate mod A bar plus B bar, I required side length of the triangle. Side length of the triangle. That's why what I am going to take in, instead of vector, I am going to consider magnitude of A bar. Magnitude of A bar. This is the magnitude of B bar. That is the length of the vector A bar, length of the vector B bar I consider. Now what about this one? Length of the vector R bar. That is nothing but R. Length of the vector R bar. That is nothing but R, resultant of these two vectors, length. So here I am going to drop a normal. Here I am going to give some name. This is M, this is N, and this is P. I am going to give in M, N, P. 3 points I am going to give in for the 3 corners. Here I am going to drop a normal. Here I am going to drop a normal on the produced MN. I am going to drop a normal on the produced MN. Means I am going to produce the MN or extended MN. I am going to consider extended MN or produced MN. That means MN is produced and I am going to get a line. On the produced MN, I am going to drop a normal. That means perpendicular. From the P to some Q. P to Q. I am going to drop a normal onto the produced MN. Now these are all lengths now. This is the length of the vector A bar. This is the length of the vector B bar. This is the length of the resultant vector. To calculate magnitude, I required all the lengths only. Length of the vectors only. I required all the length of the vectors. Length of the vectors. Length of the vector sufficient to calculate magnitude of A bar plus B bar. Is nothing but magnitude of R bar. First of all, here I am going to consider some value. Here I am going to consider some value. Some theta will be present, no? That is I am going to consider some value theta. Some value theta I am going to consider here. If suppose here I am going to consider theta, then if it is theta, what is the meaning of that we will see first. What is the meaning of that we will see first. So it is theta means I consider here theta. Here theta means I consider here theta. What is the meaning of theta here? What is the meaning of theta here? Observe here. Suppose this is nothing but angle between the vectors A bar and B bar. Here theta is the angle between two vectors A bar and B bar. Why? Because let us see. In previous session, in previous video, I explained how to calculate angle between the two vectors. My dear students, if you don't know, just check it that video once. Previous video, angle between the two vectors. You can understand clearly. I detailed explanation I given in that video. Please check it once. But here I am going to give the quick revision how to this theta is the angle between these two vectors. I will give now a little bit. Observe here. This is the A bar vector. This is the B bar vector. So let us see. This is the A bar vector. This is the B bar vector. To calculate the angle between the two vectors, there are two conditions are required. One is both the tiles meet at one point. That means both the tails of the vectors meet at one point. Otherwise, both the heads of the vectors meet at one point. But here what happened? Head of the one vector meets the tail of the another vector. Then this is not angle between the two vectors. Then this is not angle between the two vectors. Why? Because head of one vector meets the tail of the another vector. That's why this is not angle between the two vectors. At the time, what I need to do? Observe here. Parallel sliding. If I'm going to do the parallel sliding of one vector, its value does not change. That concept also I explained in previous video. Just check it, my dear students. So if I'm going to do the parallel sliding from here to here, this is the parallel sliding. What is the parallel sliding and everything I explained in previous video. Check it once, my dear students. Parallel sliding, angle between the two vectors and unit vectors I explained in detail in previous video. Please go through it. So this is the parallel sliding of a vector A bar. This is the B bar vector. This is the parallel sliding. Parallel sliding does not change its value. Then at the time what happened? Vector A bar tail, vector B bar tail meet at this point. B bar vector tail, A bar vector tail meet at this point. At the time, this is the angle between the two vectors. This is the angle between the two vectors. That's why this is the angle between the two vectors, not this one. So that's why this is not the angle between the two vectors. This is the angle between the two vectors. So that's why I said this theta is the angle between the two vectors. Remember, this theta is the angle between the two vectors. Right. If suppose I am going to consider this triangle PNQ. So this is the PNQ. So in triangle PNQ, I need to calculate NQ and PQ. If I am going to consider the sine theta, in triangle PNQ, what is the sine theta? Sine theta means opposite side by hypotenuse. What is this one? B. This is A length, this is the B length. Now hypotenuse is B. Why? Because opposite to 90 degrees in the triangle PNQ. In the triangle PNQ, this be the opposite side to the 90 degrees. That's why this is the hypotenuse. Sine theta is equal to opposite side. This is the hypotenuse is nothing but opposite to 90 degrees. Generally we call it as hypotenuse of a triangle. So sine theta means what? Opposite side by hypotenuse. Here opposite side to the theta I need to take. Sine theta means opposite side to the theta I need to take. That is PQ by sine theta means opposite side to the theta. PQ by hypotenuse is PN. From here, what is PQ? PQ means PN transpose to other side. PN sine theta. But what is the PN value? What is the length of the PN? B. That's why PQ means what? PN means B. So B sine theta. That means PQ value I got B sine theta. Now I need to calculate NQ. For that region, in the same triangle, observe here. In the same triangle, I am going to consider PNQ. In the same triangle, I am going to consider now cos theta. Cos theta is equal to what? Adjacent side by hypotenuse. In this triangle, adjacent side is NQ. Hypotenuse is PN. Transpose the PN other side. Then I am going to get PN into cos theta is equal to NQ. So from here, what is NQ? PN into cos theta. But what is PN? PN means B. So B cos theta. So NQ means B cos theta. Now NQ value I got B cos theta. B cos theta. This is the required triangle to calculate magnitude of the vector sum of A bar and B bar. Let us see. Now how to calculate magnitude of A bar plus B bar? That means R how to calculate, let us see. Now I am going to consider in triangle MPQ. Finally I need to calculate R length. R is the magnitude of sum of vectors A bar and B bar. Addition of vectors A bar and B bar. So in triangle PMQ or MPQ, in triangle MPQ, I am going to consider hypotenuse square is equal to side square plus side square. So hypotenuse square, that means by the Pythagoras theorem. So hypotenuse square, R square is equal to side square plus side square. So one side is PQ. Hypotenuse is how much? R. So R square. Opposite one side is PQ. What is PQ value? B sin theta. PQ value B sin theta. So that square plus, why? Because one side is PQ. That is B sin theta whole square plus another side MQ. Another side MQ. That means from here to here. That is how much? From here to here A. From here to here NB cos theta. But what is NB here? NP cos theta, not NB, NP. NP cos theta. NP cos theta. NP cos theta. What is NP here? What is NP here? B. B. So B cos theta. What is NP here? B. So B cos theta. So B cos theta. What is the total length here? A plus B cos theta. A plus B cos theta. Here NP means B. So B cos theta. A plus B cos theta. So this side square, that is A plus B cos theta whole square. Now R square is equal to B sin theta whole square means B square sin square theta plus A plus B cos theta whole square means we can use the A plus B whole square formula. Then A square plus B cos theta whole square means B square cos square theta plus 2AB cos theta. 2AB. So 2A means A, here B means B cos theta. A square plus B square plus 2AB. So from here R square is equal to B square sin square theta, B square cos square theta. So this is A square. Write down A square first step. And this is the B square sin square theta, B square cos square theta. From these two terms, take the B square common. In this term remains sin square theta plus from here also I took B square as a common. Then what remains here? Cos square theta plus 2AB cos theta. Plus 2AB cos theta. Now R square is equal to A square plus B square into sin square theta plus cos square theta value 1. So 2AB cos theta. 2AB cos theta. Now R square is equal to A square. B square into 1, B square only plus 2AB cos theta. Now what is R? Square transpose to other side as a square root. Now A square plus B square plus 2AB cos theta. So this is the length of the resultant vector of A bar and B bar. What is R? What is R? Magnitude of A bar and B bar. That means the length of the resultant vector of A bar and B bar. That is only R. How to calculate R? Square root of magnitude of A bar vector plus magnitude of B bar vector plus 2 times magnitude of A bar vector into magnitude of B bar vector into cos theta, where theta is the angle between these two vectors. Angle between these two vectors. This is not angle between the two vectors. This is the angle between the two vectors. Just slide the vector a bar to here. Now vector a bar tile, vector b bar tile meet at this point. Then this is the angle between the two vectors. That is only theta. That's theta only we are going to get here. That's why this is the angle between the two vectors a bar and b bar. So that's why this is the formula to calculate magnitude of the any two vectors. Any two vectors. So it depends upon the theta. If theta changes, automatically resultant vector also will change. Even though magnitude of a vector, magnitude of b vector not changed, both are constant, but their angle changes means automatically resultant vector will change. Note down. How to calculate direction of resultant vector? Why? Because R bar is a vector. It has both magnitude and direction. Magnitude how to calculate we completed. Now we are going to discuss how to calculate the direction. Direction of R bar vector. So this is the A bar vector. This is the B bar vector. Now only we consider this is the angle between the two vectors A bar and B bar vector. This is the angle. This is the angle between the two vectors. Theta is the angle between the given two vectors. Now this is what? Resultant vector. The resultant vector making some angle with the A bar vector. A bar vector. Then how to calculate that R? I'm going to drop a normal from this point. I'm going to drop a normal from this point onto the produced A bar vector. Suppose I'm going to consider this is already we are going to consider some names, no? So this is the A bar vector, this is the B bar vector, this is the R bar vector. This is the normal drawn from this point to this point. Consider this point P, this point Q. So this is M, this is M. So produced MN onto the produced MN, drop the perpendicular from P onto the produced MN. This is the produced MN. This is the MN. This is the produced MN. From the produced MN, drop a normal from P. From P. So how to calculate this? And direction. Direction of R bar means angle made by the R bar vector with A bar vector calculate. With A bar vector calculate. Let us see here. What is the angle made by the R bar vector with the A bar vector? I am going to calculate it. Then I am going to get the direction of R bar. Direction of R bar. Angle made by the vector R bar with A bar. Let us see. In this triangle, I am going to consider tan alpha. Tan alpha is a trigonometric ratio. So that's why right side all are lengths only. Length of the triangle only. Means magnitude of vectors only. Magnitude of vectors only we are going to consider. To calculate direction also, we are going to consider magnitude of vectors only. Why? Because tan alpha is the trigonometric ratio. Trigonometric ratio. Now tan alpha. Opposite side by adjacent side. Tan alpha means what? Opposite side by adjacent side. Adjacent side. What is the opposite side for the alpha? PQ. What is the adjacent side for the alpha? MQ. MQ. Already we discussed PQ means this is the it is theta. Opposite side is B sin theta. Why? Because this is the hypotenuse and this is the adjacent side to theta. Opposite side is hypotenuse into sin theta. Adjacent side is hypotenuse into cos theta. So here what already we proved. So what is the opposite side? PQ, B sin theta. What is MQ? What is the MQ? MQ means the total length I require. From here to here, magnitude of A bar vector is A. From here to here, what is the length? B cos theta. From here to here, from N to Q. M to N, A length. N to Q, B cos theta length. Then what is the total length from M to Q? A plus B cos theta. MQ length is nothing but A plus B cos theta. So this is what? Tan alpha. So by using this formula, we can calculate alpha. That is only nothing but angle made by the vector r bar with A bar. That is only direction of r bar. This is the way we are going to calculate alpha, direction of vector. Direction of vector. Note down, my student. So, final conclusion, this is the A bar vector, this is the B bar vector, this is the resultant vector. At the time, this is the angle between the two vectors, A bar and B bar, not this one, not this one. So, this is the angle between the two vectors. So, how to calculate magnitude of the two vectors? That is magnitude of r bar, root of magnitude of A vector plus magnitude of A vector square plus magnitude of B vector square plus 2 times magnitude of A vector, magnitude of B vector into cos theta. This is the angle between the two vectors. How to calculate direction of the resultant vector? So tan alpha is equal to, how to calculate? So already we proved, no? B cos theta. See, this is the vector B. This is the vector B, correct? This is the vector B. So this is making with alpha is the vector, resultant vector making an angle alpha with the A bar vector. A bar vector. At the time, my numerator starts with B bar vector. Remember how already we proved. I am going to give the trick only. If my resultant vector making an angle alpha with A bar vector means my numerator start with the other vector B. So B sin theta by B sin theta by B cos theta plus that A vector. That's all. So I am going to give the trick. What is the angle made by the resultant vector? R bar. Let us see. This is the alpha. This is the alpha. Angle made by the R bar vector with the A bar vector. At the time my numerator start with another vector magnitude. So B sin theta by B cos theta plus A bar vector length. That's all. So this is the tan alpha calculation. Okay, right. We are going to do one problem. Let us see. This is the vector I am going to consider. This vector magnitude is 3x I am going to consider. This vector magnitude 5x I am going to consider. Resultant vector magnitude 28 I am going to consider. So here given 120 degrees. 120 degrees. So we need to calculate this problem. This is the 3x, this is the 5x, and this is the 28. 120 degrees is given. How to calculate? Try to solve by the student. That's why I given a little bit time. Okay, right. How to solve? Find the magnitude of a vector. Find magnitude of two vectors. Find the magnitude of two vectors. This is the A bar vector magnitude. This is the B bar vector magnitude. You need to calculate. Find the magnitude of two vector means what is the mod A bar and what is the mod B bar. We need to calculate. So these two we need to calculate. So magnitude of resultant vector I am going to calculating by using the formula A square plus B square plus 2AB cos theta. Where A square is nothing but magnitude of A bar, that is A square, that is 3x whole square, plus B square, magnitude of B bar vector 5x whole square, plus 2 into A is 3x, B is 5x, 2AB cos theta. What is cos theta? This is not angle. This is not angle. Extend A bar vector and take here. This is the now. Just slide the A bar vector to here. To here. Then A bar vector tile, this B bar vector tile, both are meet at this point. Then this is the angle. 120 degrees means this is the 60 degrees. Why? Because these two form a linear pair. Sum of these two angles should be 180 degrees. 120 means other angle 60 degrees. The theta is equal to 60 degrees is the angle between the two vectors. Now cos theta, where theta is the angle between the two vectors, that is 60 degrees. Substitute here. Now 3x whole square means 9x square. 5x whole square means 25x square, plus here cos 60 means 1 by 2. That's why leave it 2 here. 3 5 is 15 x times x square. Cos 60 means 1 over 2 off. So 2 get cancelled here. 2 cancel out. So 2 get cancelled into one time. So here what happened? 9x square, 25x square, 15x square. So 15 plus 25, 40, 40 plus 9, 49x square. From here, 49x square, 49 bring out from the root as a 7, x square as a x. Finally, our magnitude of resultant vector we got 7x. But in the problem, r is given. 28. Then r value 28 is equal to 7x. 7 get cancelled out in 28 4 times. Then our x value is 4. If x value 4 means, what is the first vector magnitude? I consider 3x. Given is 3x. That is 3 times x. 3 times x is 4. 3 times x, 3 4 just 12. Second vector magnitude, that is b bar. How much is given? 5x. That is x is, we got 4. X value we got 4. That means 5 times 4. 5x means 5 times 4. 5 4 just 20. So magnitude of vector A bar is 12 units. Magnitude of vector B bar is 20 units. Those two things we require. What is the magnitude of A bar? 12. What is the magnitude of B bar? 20. So these are the required magnitude of given two vectors. Thank you, my dear students. In next session, we will continue with another concept. Thank you, students.